Thank you for the opportunity to present an environmentally friendly initiative where we can harness the power of the African sun to replace our diesel consumption, which not only costs more, but is extremely harmful for the environment. In this presentation, I will begin with a trip back to memory lane when we first built the hotel, explaining the context that drove our development decisions. I'll follow with the problem statement that will give more information regarding our current operations in the context to the current environment. I will then highlight some of the successful initiatives we have adopted and illustrate how it has benefited our organization. I will elaborate on the opportunity of how harnessing the African sun will benefit us now versus when we were constructing the hotel. The proposed changes section will provide a more detailed analysis on our current power usage and the impact of changing to a new method of thermal heat generation and the investment cost to make the switch. Finally, the timelines and metrics section will first illustrate the savings from solar power and its impact on our bottom line, as well as how long it will take to adopt this initiative. First, I'll begin with the context of our situation. When we first opened the hotel in 2007, there were many sustainable technologies being adopted, but they were extremely expensive almost 15 years ago. LED lights had not been perfected, nor did it have bright enough lumens compared to what incandescent and compact fluorescent lights had at the time. So we opted to use halogen bulbs since they were much cheaper and provided the necessary lumens our guests expected. We also installed a diesel boiler because solar technology was also very expensive and could not heat water and retain its temperature for as long as we needed to meet our guest expectations. We designed and built our existing property based on the information we had at the time in combination with our profit expectations to meet our debt obligations. However, the situation on the ground has changed, which leads me to my next slide. The next section will highlight the high-level problem and a solution for it. We are now over 10 years into our operation, and the way we currently operate is not aligned with the values of our organization, nor is it aligned with new technologies that are more efficient and better for the environment. Our operational costs are not being minimized as fuel prices keep increasing. Our boilers are almost 12 years old, and they require more maintenance as they age. New technologies, such as solar cells, have become cheaper, and retaining thermal heat has improved dramatically over the years. Even LED lighting has become a lot cheaper, better performing, and more efficient since 2007 when we started to design the hotel. Switching to these technologies will incur an initial cost, but the investment will reduce our operating costs and consequently increase the valuation of our organization. Furthermore, switching to renewable and low-emission technologies will improve our competitive position in the market and as well improve our compliance in ESG due diligence audits that investment firms require when we decide to exit from the market. I will now discuss some successful initiatives we have adopted and illustrate how they improve our bottom line, as well as how we score on the United Nations World Tourism Organization Hotel Energy Solutions Assessment. In the third quarter of 2017, we switched all our halogen lights in the hotel to 5-watt LED GU10 bulbs. We spent $30,000 to make the full change. The reason why we switched was to reduce our energy bill, but also to reduce our carbon footprint and comply with the Intercontinental Hotels Group Green Engage brand standards. The result was a 90% reduction in our lighting consumption, which brought our electricity bill down by $150,000 in 2018. This savings increases our business valuation at a 10 cap rate by $1.5 million. This example explicitly illustrates how adopting sustainable operating practices is not only dramatically helpful to the environment, but also to our bottom line. I input our energy consumption data, our occupancies, and hotel-specific information into the United Nations World Trade Organization Hotel Energy Solutions Assessment application to see where we stand with respect to our energy performance. I was pleasantly surprised to find out that we have an A grading, which is something to be proud of and celebrated. As I reflected on our score, I realized that we thoughtfully designed our public areas to take advantage of the tropical climate. We don't use HVAC in our public areas, as they are open spaces with high ceilings and natural airflow due to our temperate tropical climate and thermal mass construction. However, we have a further opportunity to improve our energy efficiency by harnessing the power of the African sun. As we celebrate our successes, it's both prudent and wise to acknowledge that we can also do more. Doing more further helps the environment, lowers our carbon footprint, and improves our bottom line. As I stated in a previous slide, we have a massive opportunity to harness the power of the sun, which was not a viable option when we first built the hotel. This graph illustrates an exponential drop in prices of solar modules. It shows the change in price from different sources of power in the last decade. Solar photovoltaic has dropped by almost 90% in the last decade, and solar thermal has dropped by 16%. What's also important to note is that the amount of solar thermal panels needed to generate hot water is significantly less than the amount of solar panels needed to generate electricity. When we started building the hotel in 2007, adopting solar was not financially feasible. However, now it's both financially feasible and makes sense despite the switching costs, which I will elaborate on later on. From the same Hotel Energy Solutions UNWTO assessment, I discovered that our current supply of energy comes from 32% electricity and 68% fossil fuels. We use quite a bit of diesel, using a boiler to heat up our water calorifiers, to service our guest rooms, as well as to create steam for our laundry plant, which also heats our swimming pool. This bar graph clearly illustrates how much greenhouse gas emissions are being produced from burning oil versus solar. Oil emits 144 times more emissions than solar, which is killing our environment and causing warming at unprecedented levels than the Earth has ever experienced. We have an opportunity to exhibit positive change in our lives by aligning our values with our business practices, making our organization even stronger and cleaner. The Hotel Energy Solutions UNWTO assessment identified an opportunity for us to increase our profits, competitiveness, sustainability, responsibility, as well as further aligning our brand values with our international franchisor and the UNWTO climate change initiatives. By reducing carbon emissions, we will see a reduction in costs, energy consumptions, carbon footprint, as well as our impact on climate change. By capitalizing on the sun's limitless supply of energy, we will have a lower environmental impact and get closer to having energy independence. This will help us align our foundational values of ethical business practices with our guests' expectations. In this section, I'm going to tell you more about the solar water heating technology that I'm proposing and how we stand to benefit from investing in it for our property. As you can see, there are two types of solar technologies. On the left is solar thermosiphon, and on the right is solar thermodynamic solutions. Most companies are investing in thermosiphon as it's more readily available and cheaper to install. Thermosiphon is mainly made of glass and has to be south-facing to get maximum benefit. The downfall of this technology is that it needs a large area for installation. It must be cleaned continuously to maximize solar absorption, and its performance decreases over time. Solar thermodynamic, on the other hand, does not need to be facing the sun. It is made of aluminum, and it absorbs the ambient heat in the air throughout the day and night, and therefore doesn't need to occupy too much space or face the sun in a specific direction. It can actually be hung on the side of the wall, hidden, and still work effectively. Solar thermodynamic is perfect for tropical and desert environments, as the weather is relatively warm throughout the year. We typically consume 18,000 liters of diesel a month on average, which translates to a cost of 15,300 euros a month of diesel. If we switch to the thermodynamic system, our cost efficiency would improve as we would be using a smaller amount of electricity to boost the heat throughout the night, which is less than half of what we spend on diesel at about $6,400 a month. We save almost $9,000 a month, or just over $100,000 a year on operational costs from switching to solar from diesel. But yes, there is a cost to switch, which I'll tell you about next. I am proposing two systems. The first system will contain an 18,000 liter supply to our old guest wing of 162 rooms. This will be enough to service our guests even if we're at 100% occupancy. This system will cost 190,000 euros. We would also need to change the system that supplies the kitchen and laundry area with an additional 6,000 liter at a price of 63,000 euros. Both systems combined will be about 250,000 euros. This system comes from a Portuguese company that has been used in Eldoret, Kenya, Mauritius, and Radisson in Abu Dhabi. 250,000 euros is a large amount of money to deploy to realize gains after a number of years, which is why I propose to not use our money, but instead finance this investment and pay for it with the savings we make from using a more efficient energy source. As illustrated before, we consume $185,000 of diesel a year. The cost for the electricity to boost the solar is $77,000, which is not being used all the time. This is savings of about $108,000 a year, or about $9,000 a month. We can finance this project at 7% for 3 years from our existing lender, which will cost us $7,700 a month. The difference in the savings we get from the solar project and the financing costs are about $1,300 a month in our pocket. After 3 years, we've paid the whole system off and realize a savings of $108,000 a year. This translates to just over $1 million increase in valuation. Although the LED project we did had a lower investment cost with a higher valuation increase, this project, although has a higher investment cost and a lower valuation increase, it still has a net present value greater than zero, and therefore creates shareholder value. Furthermore, it doesn't require any cash outlay as it can be entirely financed. Also, migrating from diesel to solar still allows us to use our existing plumbing infrastructure without incurring any additional mechanical engineering infrastructure costs. Lastly, the intrinsic value to our organization also increases as we adopt lower carbon emitting technologies in operating our hotel. We can use this to market our property to both customers and potential buyers who require ESG compliance from their organizations. This project would take about 3.5 months to complete from payment of a deposit of 50%. It will take us 3 months to receive and clear the goods and 2 weeks to install and test. By harnessing the power of the African sun, we further entrench ourselves as leaders in adopting energy-efficient operating technologies that both improve our carbon footprint and drive operational performance. Solar thermodynamic water heating system is more efficient than the traditional thermosiphon model. It's great for the environment. It helps us to meet our ESG green engaged targets set by our franchisor. It makes us more competitive in the market and increases the valuation of our property. Thank you.